today's video we are going to be talking about Newton law of motion, which is based on physics. This is one of my physics video. The other one I lectured on biology. So yeah, we're going to be talking about the Newton law of motion. Now, just like we all know that Newton law of motion can be stated in three ways. There's the Newton first law, the Newton second law, and the Newton third law. So we're going to talk about and explain each of them one after the other. So let's begin. Newton laws of motion. So we have the first law. Now there is this Newton first law of motion. Now this just says that an object at rest will remain at rest unless acted upon by an external force. Now this Newton first law is also known as the law of inertia because inertia is the tendency of an object to resist changes in its motion, like changes or in external force. So now this first law states that an object at rest will remain at rest unless acted upon by an external force. Now, whenever an object is placed down, let me say we have an object of 100 kilogram. This object here will remain at rest, will remain here unless an external force, the external force may be wind or wind or human, maybe will come and move the block. Now, this because this block will remain here, not that except this external force, which is maybe can be wind or human that can maybe move it, can displace it. Now, the main reason is also called law of inertia. Just like I said, inertia is the tendency of an object to resist changes in its motion. Now, for example, we have a body of 100 kg, right? What if we have a body of 1000 kg? Okay, for this body of 100 kg, it can be easily moved, easily pushed away. But this body of 1000 kilogram, for it to be displaced of an external force to act on it, it's going to be harder. So we can say this 1000 kg block has more inertia than this 100 kg block. So the higher the mass, the higher the what inertia. So that is the Newton first law of motion. Now we're going to talk about the second law also. Then we can move to the third law. Second law. The Newton second law of motion can be stated in two ways, but there is a main aspect that is mainly used. So like this is the explanation I'm going to give. Now this one says that the acceleration of a body is directly proportional to the applied force and takes place in the direction of the force. Okay, and also like inversely proportional to its mass. So like this law, okay, let's we have this formula. F is equals to ma. For easy understanding, we just have F is equals to ma. The acceleration of a body is directly proportional to the applied force and but inversely proportional to its mass. Now, this says that as acceleration increases, the force also increases. But when acceleration increases, the mass decreases because they are that means acceleration and mass they are inversely related, but acceleration and force they are directly related because acceleration increase, force also increase. Because okay, so let me say we want to find the force. So let's say acceleration. Because so if we want to find acceleration of a body, that will be F over m. Divided beside by m. So if we want to find acceleration of a body of let me say with a force of 100 Newton to a block of let me say 20, that will be acceleration will be 100 divided by 20, which will give you 5 meter per square second. So for you to so whenever acceleration is because the more you apply a force to an object, the more it will accelerate. But if a body have a larger mass, for you to accelerate that body, it will be very difficult. That's why acceleration and mass they are inversely related, but with force they are directly related. So let's move to the third law of motion. This is the main aspect. So I'll just have to wipe this off. Okay. Move to Newton third law of motion. Now, Newton third law of motion. Now, this law says that for every action, there is an equal but opposite reaction. Now, Every action, there is an equal but opposite reaction. Let me explain. Let me say, for example, we have a body right here. Now, if you apply a force F on this body will also apply a same force F, but on you too. Let me say, okay, let me say you hit this block, you also feel an opposite force. This force, let me say the force here is 20 Newton. This force that this block will also exert on you will also be 20 Newton, but they are equal in what direction? Because this direction is facing like this, and this one is facing what, like this. Now you cannot say they are equal in magnitude, because 20 Newton and 20 Newton, but they are opposite in what, that direction. The direction are opposite. Now, this this third law of motion can be in everyday aspects. Even for footballers kicking a ball, whenever they kick a ball, they will also feel that opposite force, like the same force, but not because they have, like, because they are maybe larger in mass, that's why you can't feel it like that. Okay, if you want to test this practically, let me say, like, your example, you're in a ship. Okay, let me just say a canoe, like, and you're a canoe, like, just try to throw a ball, a basketball. You will feel a force on you, but like, which is the same in magnitude but opposite in what direction. That is the Newton law of motion. This is the Newton first law, the second law. Just like we said, Newton first law, also known as law of inertia, which is an object at rest will remain at rest unless acted upon by external force. And Newton's second law, where I have F is equal to ma, like I said, the acceleration of a body is directly proportional to the applied force, but inversely proportional to its mass. And the third law says that for every action, there is an equal but opposite what, the action. Now we're going to be talking about. Okay, I have a question. Now, if we have, okay, when we say weight and mass, what's the difference? What's the difference between weight W and mass M? Now, we all know mass is the quantity of matter in a body, right? What about weight? Yeah, weight is a force. Yeah, weight is a force, is the gravitational force, like the gravitational force in which the earth is pulling us down to the ground, to its center, right? Now, this weight is a force. Yeah, force is measured in Newton, right? Force is measured in Newton N. Why mass is measured in kilogram, right? And also weight is also measured, weight W. Force is measured in Newton, weight W is also measured in Newton. Weight is the force, while mass is the quantity of matter in a body. Now, please, my next video, I'm going to do some problem on this Newton law of motion, where we're supposed to use our force formulas to solve some problem. So please like, follow, and subscribe for more. And also, please, you can please tell us the formula to calculate weight on the comment section. Now, thank you all and have a nice day.